Hello creative shrimps, Gleb Alexandrov here, welcome to yet another tutorial from the Photogrammetry course. I'm pretty excited because in this video we'll explore the Photogrammetry workflow, which is 100% open source and cross-platform. Before we begin, that's the software that we're gonna use, so feel free to download it. Darktable for pre-processing the raw files, Meshroom as our main photogrammetry tool for this tutorial, and Blender obviously as a multi-purpose 3D editing tool for cleaning up the mesh and baking textures. A quick disclaimer though, it might be not the most optimal photoscanning workflow. There are tools and applications that are simply faster than Meshroom and say more convenient than Blender when it comes to baking, but it's definitely the most accessible photogrammetry workflow at the moment, so let's get started. Here is a brief introduction to what the capturing process looked like. So we went to this abandoned post-Soviet hangar, found this amazing cellophane and pretty much shoot it from all possible angles while following the best practices of photogrammetry, mainly keeping the ISO at its lowest number, setting the f-stop to 8 to make sure everything is in focus, and then using tripod to calibrate the shutter speed as we like it. When shooting on tripod, the shutter speed can be any number we like, no shaky hands involved. But to stay on a safe side, we set the timer to 2 seconds as well to reduce the camera shake on pressing the button. That is pretty much it for the photo session. We have covered these settings extensively in the first chapter of the course. Oh, and we also took one photo of our X-Rite color checker gray card to be able to calibrate the white balance in post. The whole scan took 107 photos on Canon 80D with Sigma 17 to 55mm lens. The source photos as well as the blend files are available for download, so if you want to follow along with us, consider downloading these photos. Before starting the photogrammetry process, let's actually process the raw sources in Darktable, a free and open source software for developing the raw files. So right away, I'm gonna open the folder with all the photos that we have taken during the scanning session, and then I'm simply dragging it into the central window of Darktable. If you don't have the panel on the left, you can hit the triangle to open it up, and there we can check the metadata or the image information. There is a lot of interesting data in there. What were the camera settings? For example, f-stop was set to 8, apparently exposure at 1/2 of a second. The ISO is just 100, which is awesome. And it never hurts to double check if it's the raw file indeed, which it is. We can tell it by the CR2 format. On the right, we should also have the open panel with history stack and export settings. Right now we're in the light table mode, in which we simply preview all of our images, and we edit them in Darkroom. You can access it by double-clicking on any image. Let it be the image with the gray card that will serve as a reference. Down in the Modules tab, I will activate all modules just for a second to showcase something. The thing we should watch for when developing the raw files in Darktable is whether the base curve has been disabled. Occasionally you may discover that some kind of a preset has been applied. These curves are similar to the in-camera processing that is applied automatically when you shoot in JPEGs. That's something that we should avoid when shooting in RAW, so here goes the reset button. We should keep the contrast curve linear or disable it altogether. Alright, now I'm visiting the Modules drop-down menu and selecting the Scene-Referred Workflow. That's the preset that contains all the modules that we'll need in this tutorial. And next I'm gonna check the tabs at the top of the shelf to make sure that pretty much all the modules have been disabled. And it seems like it is the case, except the Filmic RGB that should be also turned off, because it also implements a kind of a curve, and we should be suspicious about any kind of curves when developing our raw data for photogrammetry. In other words, we're trying to stick to the sensor values as close as we can and avoid the transformation that are meant for display. So to calibrate the colors and make them closer to the reference in the source photo, we should adjust the white balance first, the temperature slider. Thankfully, we have the gray card in our scene, so we can set the custom white balance with the help of such card. If you don't have a card though, don't despair. Try to find the area in the photo that is supposed to be as close to neutral gray as possible and select it, or it's always possible to eyeball it a little bit. So here we have the scene illuminant that is approximately 6K kelvins. What we can do next is adjust the exposure in a similar way. because we have the 18% gray card, and we can use the color picker tool in Darktable to read the lab values of these pixels right here. And this value, according to the specification of the X-Rite color checker, should read as 50 in the lab terms. To double down, we know it for a fact that if we want to align these values with the values of the color checker, which is our reference, it should read 50. So what I'm doing here is carefully nudging the exposure value to the right and then clicking on the color checker and checking again, increasing the exposure a bit more. 44, close enough to 50. Now I'm gonna enable the tone equalizer module to try to reduce the influence of the light sources on the scene. We can do it in two ways. We can, of course, adjust the sliders, like the 0 EV slider here, or we can hover the mouse cursor over some area of the image and use mouse wheel to adjust the sliders. Something like that. It's not a physically correct operation and it shouldn't replace a proper delighting, but that's a decent starting point for pre-processing photos for photogrammetry. I usually follow it up by switching the highlight reconstruction to reconstruct color. That's an additional measure to preserve some highlights that otherwise will get clipped. Alright, getting back to Darktable where we have all our photos arranged. So we have adjusted this particular image. Now down in the history stack I'm pressing selective copy, making sure that the white balance is included. That's important. And pressing OK. Now Ctrl A to select all images at once. In the history stack, selective paste, and happily confirm the operation. The adjustments made to the photo with the color checker should now propagate to the rest of the sources. It looks good to me, I think. Now we should be ready to export this batch of images out of Darktable. So I'm heading over to the Export tab, pressing the Browse icon. I've created two folders in advance, one for geometry and the other one for texture, and they are called like that: Meshroom Geometry, Meshroom Texture. I'll explain why in just a moment. So let's enter the texture folder, set it as the output destination, and now we should check two things. The first one is the output resolution, and I'm limiting it to 2500 pixels wide. Why do we do it though? Why not simply use the full resolution? Firstly, to reduce the processing times, secondly, to reduce the file size, and finally, and probably most importantly, we found out that pre-scaling the footage before feeding it into Meshroom leads to better results than using the higher downscale factors within Meshroom. And then we should check the file format, that should be 8-bit TIFF, and hit export then. After this batch of images meant for texturing have been exported, let's do another batch for geometry. Disclaimer, this step is not absolutely necessary. Meshroom will work just fine with just one set that we have prepared already. That being said, it's very useful to know how to prepare the split input for geometry and textures in Meshroom, so that's what we're gonna do. Double-click on any of the sources to enter the darkroom mode. This time I will prepare the more contrasted versions of the image, so tone equalizer set to off, the local contrast can be set to on instead. I will try to boost the overall sharpness and the amount of fine detail in the images. In theory, that should help Meshroom to reconstruct the better mesh. So let us also enable the sharpen effect, crank up the amount all the way to 2 to its maximal value. Not that the whole process wouldn't work without all these sharpening shenanigans, but anyway, it's useful to explore this branching workflow of feeding two types of sources to Meshroom. So once again, click on Darktable to get back to our Darktable tab with all the previews. Selectively copying all the settings, including white balance. Ctrl A to expand the selection to all photos, and then selective paste all modules onto them. Looks like the processing has been finished, so we just have to export it out to its separate folder. Clicking on the Browse icon, back to the folder. And now let's dump it into the Meshroom Geometry folder. It is important that the resolution or the size of the images line up with the previous folder, so 2500, and pressing the Export button. After pre-processing the raw files in Darktable, we should have two folders. The one with the images calibrated for texturing based on the reference gray card. Don't worry if it looks a little bit too flat and boring. It should look like this. It is meant for albedo textures. And here's the second one with the files aimed at reconstructing geometry, slightly sharpened, with boosted contrast and so on. Right, so we did all the pre-processing required for photogrammetry in Darktable, and now we can actually move on to Meshroom and start the photogrammetry process going. Now on to reconstructing a fabulous 3D model out of the processed photos in Meshroom. Before we get started, feel free to download this free and open source photogrammetry software from alicevision.org. So the first thing we need to do is import the photos that we processed in Darktable into Meshroom. In order to do that, I'm gonna select the photos from the geometry folder and drag them onto the images window. So once we load up our source photos into Meshroom, we should see it over there. The scale of the thumbnails can be changed if we wish. So these are the photos that we have pre-processed for geometry. We can click this icon to check their metadata and see if everything is alright. For example, it's worth checking the resolution to see if those files are the files that we think they are. Looks okay to me. And now we can press this enticing green button that says start. Actually, no. We should really use nodes one by one in the graph editor. It's much safer to approach Meshroom in a modular way and activate these nodes one by one until we reach the final destination, which is the texturing node. That's gonna be the last one. But we should be definitely proceeding through this chain on a node-by-node basis. So I'm gonna right-click on the first node and compute it. Meshroom prompts an error that we should probably save the file first, so let's heed the advice. File, save as. Name the file somehow. I won't be insisting on particular naming. Okay, now we can right-click and compute it again, and we can see that the progress bar became green. It means that the node has been calculated. Every node in Meshroom has the attributes that can be changed, and some of them can be seen only if the Advanced Attributes checkbox is ticked. But at the same time, this checkbox makes everything convoluted, and the default settings are more than enough in practically all cases. But at the same time, there are some useful settings that can be seen only with this checkbox set to on. For example, the Force CPU Extraction checkbox, which can be switched off for a slight benefit in speed, but generally it isn't that important to see all the advanced attributes. Well, okay, returning for a moment to describer density and describer quality, these two settings definitely have the most influence over the processing time and the resulting quality of the feature extraction node. I will go with the flow or with their default values, but feel free to experiment. The right-click menu, compute. The progress bar on the node has turned orange, meaning it's processing. Once it's finished, it will turn green, and that's how we know that it's fully processed. Now, for example, we know that every feature has been processed. We can click on the Display Features icon in the image viewer to see those markers or sift features. Basically, Meshroom detected a bunch of points for every photo, and in the feature matching node, these points will be matched to then create the structure from motion. But first, let's compute the image matching node, then proceed to feature matching. No need to touch the settings, the default values are just fine for these nodes, probably all the way until the depth map node, based on our experience. So right-click, compute. To track the progress, we can head over to the log window, and we will see the chunks there. Each chunk has to be processed until the node is calculated and marked green. And here we can see the progress bar for each chunk as well. The chunks, just like the nodes, are also marked green on finishing. So it took approximately 7 minutes to calculate the feature matching node. I'll be logging the progress, just in case. Then onto the structure from motion node. As you can see, the calculations become progressively longer and longer, and this node definitely will take a considerable chunk of time. Whoop, 20 minutes to be exact. Whoa. It's quite typical for photogrammetry and for Meshroom photogrammetry too, of course. I feel there might be an opportunity to use a wise quote here. To lose patience is to lose the battle, by Gandhi or something like that anyway. But what do we have here? It's our structure from motion that has just finished processing. Alright, we can see the generated result in the right-hand panel. The visibility can be toggled on and off by pressing the eye icon. We can read the number of points there and the number of cameras that have been matched. 107. All cameras have been matched, and that's great. Then in the top right corner of the UI, we can change the scale of the points and the scale of the cameras as well. I try to keep these values pretty low so the viewport doesn't look as cluttered. Alright, by looking at the viewport, we can tell that the orientation of the model is a bit weird. What we can do is add the extra node after structure from motion. In order to do that, we need to create some room. So I'm gonna move it like this to the right, node by node, until we free up some space over there so we can plug the node. Right click on the empty space, go Utils, SFM Transform. The SFM data should go into the input, and then right click and remove this existing connection and hook up the output SFM data file to SFM data input of the prepared dense scene node. We can choose from different transformation methods, but let's try auto from landmarks. Hopefully that will fix the orientation issue. Let's compute the node, double click it to open it up. Let's toggle off the visibility of the original structure from motion, and I think something is wrong. Let's try unticking the scale and translation checkboxes and just play with rotation instead. Okay, double click again. Alright, awesome, that did the trick. I think it improved the orientation of the point cloud. It's far from perfect, though I think it can be adjusted furthermore. Say, if we'd like to tweak the orientation of the point cloud manually, we can do it too with the help of the SFM Transform node. So I'm gonna repeat a somewhat tedious process of moving it node by node to the right, and then I'll hook up the second SFM Transform node in between these two. Something like that. The transformation method now should be set to manual. That gives us a gizmo with scaling, rotation and translation controls, so we can place the mesh, or rather the point cloud, manually somewhere in the scene. Let's toggle off the visibility of the original object and use the gizmo to carefully rotate and translate the mesh until it rests on the grid, like this. There are two gizmos now, one for navigating in the viewport and the second one for rotating the mesh. You can click on this hide gizmo icon to hide it temporarily. Optionally, this alignment step can be skipped altogether, because we will be tweaking the orientation of the resulting model in Blender anyway, but I'm too pedantic to skip it. I really want to see the correctly oriented mesh right here, right now in Meshroom. Alright, after doing the quick alignment, we can proceed to calculating the rest of the chain. Preparing the dense scene for depth maps won't take long. Just a few seconds at max. But then it's time for the depth map calculation. That beast can definitely take an insane amount of time, especially if the downscale is left at 1, meaning the original resolution. In other words, if the downscale is set to 1, Meshroom divides the source photo resolution by 1, meaning it uses the originals. If the downscale was set to 2, Meshroom would divide the resolution of the source photos by 2 before processing the depth maps. If the factor becomes 4, Meshroom downscales it furthermore. Now it is a rhyme. Let us go with the downscale of 2 though, taking into consideration the already halved resolution in Darktable though. So by taking that into account, it's like 4x optimization already. In addition to that, there is a whole bunch of advanced parameters, which I really don't recommend touching. The developers of Meshroom don't recommend tweaking it as well. So let's listen to them. It's simply not worth it. Alright, calculating the depth map now. There should be enough time for a cup of coffee or green tea if you're up for it. In order to predict how long it will take, we can once again check the log. Each chunk that has been processed shows the time that it took. So to approximate the remaining time in a kind of a rough way, we can multiply the time as seen in the finished chunks by the total number of chunks. For example, we can tell that the depth map chunk number 12 took approximately 19 seconds to complete. And then let's say we have 35 chunks in total. That means 19 multiplied by 35. What is it? 660 seconds or 11 minutes. It is a very rough ballpark though, because chunks can take different time to calculate, but that gives us some figure to work with. allow me to fast track the result though. Anyway, it took about 11 minutes indeed. I think it's actually pretty fast because we have downscaled the sources in Darktable, remember? That is so totally worth it, downscaling. If you feel like waiting a little bit longer and potentially getting more detailed result in the end, then just feel free to bump the downscale value all the way to 1. It is a little bit scary though. Anyway, I'll proceed to calculating the depth map filter node, which is really quick to calculate as opposed to the depth map node. Alright, so with the depth map calculated and filtered, it is a high time for materializing the 3D model itself. The colorize output can be turned on if you want to check the vertex colors, but I don't see a real need for it right now. Then we should probably consider switching on the custom bounding box within the meshing settings. That would really help to cut the garbage and optimize the reconstruction speed. Right away we see no change after ticking this checkbox. That's because we need to double click on the meshing node, that's important. And then we should see this new model in the scene tab. And we can hide the bounding box if needed by clicking on this icon. Alright, so we can adjust the reconstruction region by manipulating this gizmo, but it's somewhat obstructed by this second display gizmo. Thankfully we can disable it by clicking on the display trackable icon. And now we can move, rotate and scale this thing so the bounding box encapsulates our mesh in the most optimal way. Like, do we really need to render everything or just this clothy object? Maybe we can save some resources by constraining it like that. Sometimes it's a life-saving optimization if, for example, you have scanned the entire city area and you want to render just this building. Okay, with the bounding box ready, we can go ahead with the mesh reconstruction. That is pretty exciting. We will see the fully fledged photoscan, the fully fledged 3D object for the first time, and we will tell if it's good or not. Of course, I already know that, but anyway. I will disable the bounding box, re-enable the trackball in the viewport, and what can I tell? Except these floaters at the bottom of the model, everything else looks great to me. Actually, better than I expected. This is our photoscan and it is actually good. I'm really happy with it. Now we can either proceed to the very end of the chain and do texturing, or we can do the cleanup in Blender and then do texturing instead. And that's probably what I'm gonna do, because I want to change a few things with the mesh. So after creating the publish node, I'm connecting the mesh output into the input files, and then the output folder needs to be selected. We can do it like this, at least in Windows. After opening the folder, right-click on its name, copy address as text, and then paste the text over there in the output folder field. And lastly, right-click on the node and compute. After that, an OBJ file that contains our Highpoly mesh should appear in that folder. In just a moment, we will bring it into Blender for some cleanup. In this part of the video, we're gonna mesh doctor our 3D model in Blender and then bring it back to Meshroom for some texturing. So fire up Blender, go File, Import, choose OBJ, navigate to the folder with the model, and hit Import. So that is our mesh, but before doing anything with it, I'm gonna right-click in the bottom of the user interface and enable Scene Statistics. So we can see that it's approximately 1 million vertices and 2 million faces. And wow, it seems that the Z-axis was flipped. We thought that we sorted out the orientation, but not as fast. It isn't recommended to change the mesh orientation itself because it has to be re-exported back to Meshroom, so I created the empty object instead. And I'm gonna parent our mesh to this empty object. Select both objects, with the empty being the last one. Right-click, parent, object. Now, on rotating the empty objects, the mesh will follow all the changes in Transform. And in addition to that, our empty will record the changes that we do, so we can roll it back just before exporting it out, so then it all aligns perfectly with the Meshroom coordinates. Okay, next I will add the cylinder that will serve as the Boolean cutout object. Let's crank up the vertices count to make the cutout a little bit smoother. We can click the X-ray icon to see through things, and S and X to scale the cylinder horizontally on the X-axis. And then I'm going to select the Photoscanned asset, come over to the Modifiers tab and choose the Boolean modifier. Right away I will switch it over to the fast mode, because well, it's fast, and we are dealing with considerable number of polygons, and the mode should be switched to intersect instead of difference. Then I'm going to pick the cylinder as the operand. And that constrains the asset to the shape of the cylinder. Now we just have to apply the modifier. And lastly, we can select the Boolean object, press X and get rid of it. And toggle off the X-ray mode. Alright, so technically what we did is just imported this Photoscanning into Blender, modified it. We could have edited the mesh itself or applied any kind of modifier or adjusted it via sculpting, for example. It doesn't matter much at this stage. What we did is made some change to the mesh, but because we have the empty object around, we can revert the transform of the object and get it back to reality capture for some texture projection, for example. Alright, so far so good. Should we show some sculpting techniques though that may come in handy? What do you think? Alright, I think we can take this risk and stretch this section a bit more to show how the mesh can be cleaned up via sculpting, just in principle, you know. By the way, now I will save this blend file to load it up once we mess it with sculpting. Just keep in mind that this sculpting section is not supposed to be followed along, or you can obviously do it if you wish, but be sure to save the file so we can get back to it. Often, if the photoscan is good enough, cleaning it up means denoising it. The high-frequency perturbations in the geometry is the scourge of photoscans, and the Blender sculpting mode comes to the rescue. In the left tool shelf we can find all the brushes, and if the mesh is dense enough we don't need dynamic topology, and I think 1.7 million polygons is already dense enough. And now, what brushes could be useful for denoising the geometry? The flatten brush comes to mind instantly. It's my favorite brush for this kind of task. It works in kind of a simple way. It really does flatten the geometry. It can't be put better than that. The strength can be controlled at the top of the user interface, and that's especially useful if you do it with mouse. If you use tablet, the strength can be controlled via the touch intensity. And needless to say, that makes the whole process much more intuitive and just generally faster. And then you just gently massage the mesh along its curves, and the flattened brush is intelligent enough to not wipe out all the detalization in those places. That is my #1 brush when it comes to manual mesh denoising. It's really good. Then we have the smooth brush that can alternatively be invoked with the help of the Shift hotkey with any kind of brush. It is even more nuclear than the flattened brush, so you have to control the strength if you don't want to transform everything into marshmallow. But in small doses, that's also a nice medicine for the noise. The third brush, which you can place roughly in this denoising section, is the scrape brush. Actually, the settings for all the brushes can be found in this menu. Say, if you want to adjust the radius, the fall-off, the strength, the direction, the texture, whatever else, it can be done from this menu. You can explore it if you wish. So even though the scrape brush works kind of similar to the flattened brush in terms of polishing the surface, it has the very strong hard surface connotations. Imagine having to clean the photoscan of some mechanically engineered surface, something along these lines. It's a fairly unique brush, and it fulfills this unique role. It's very easy to overdo it though, so I would be careful with using it. Again, maybe in cleaning up the mechanical surfaces it has its place, but it's a little bit, you know, freestyle. So the flattened brush is super useful for reducing the noise, the smooth brush, then probably the scrape brush from time to time. If the photoscanned mesh has some really cursed spot that has to be filled with concrete, then the clay brush may come in handy. It literally builds up the virtual material in crevices so we can fill the entire caverns of chaos with this clay. And sometimes it's the last resort. It's the last thing that we can do to clean up the photoscanned mesh. Now loading up our backup as promised. What I recommend to do with such meshes is just give it a slight treatment of the flattened brush. By the way, the tool shelf with the brushes can be toggled with the help of the T shortcut. So what I'll do here is apply a small and fairly insignificant layer of flattening with the flattened brush, obviously. I will fast track this to not bore you to death. And at this point, I want to encourage you to try the sculpting brushes, the flattened brush specifically, to see what you can squeeze out of this mesh in terms of quality. And once you played with the baking tools, we can export this cleaned up and sculpted mesh back to Meshroom for some texture reprojection. Alright, so let's imagine that we have done everything that we wanted to do with this mesh. We trimmed it, we sculpted it out ever so slightly. What we need to do now is open the right tool shelf with the Transform tab and reset the rotation of the empty. As we remember, all the changes in orientation have been recorded in there, so let's input 0 in the X rotation field and that will bring it back to its original value. If we did everything right, after exporting this mesh out back to Meshroom, it should align perfectly with the previous parameters. So I'm using the OBJ export once more, creating a separate folder for it called Highpoly tweaked. Limit the OBJ export to selection only. The other properties should be left at their default values within the Geometry tab. And I think we should be good to go, maybe after renaming it. Highpoly tweaked. After successfully exporting it out, we can press Ctrl Z a few times to undo a few steps and bring back the rotated version of the empty. Chances are, we may want to return to this file later on and fix something. After our mesh has been cleaned up in Blender, it's time to return back home into Meshroom and do some more texturing. We don't need the Publish node anymore, so I'm gonna hit Delete. Now we have mesh filtering and texturing nodes to do. Let's push them over to the right like this to free up some space here. Then I'm gonna right-click, go Mesh Processing and add the Mesh Decimate node. This node will be our workaround to actually load the OBJ mesh from Blender, otherwise we'll simply get an error that I'll show in a moment. So I'm removing the connection that was previously going into the mesh input of mesh filtering and reconnecting the output of Mesh Decimate instead. Next we're gonna define the input of our freshly created OBJ file here. So I'm gonna drag it over there. Let's also set the simplification factor to something insignificant like 0.99, just for the purpose of reworking the vertices of the mesh basically. Right-click, compute. As I've said, we need to do it like this because for some reason mesh filtering node doesn't accept our mesh. I don't know why really, it could be a bug. Actually, let's try it out. I'm gonna paste the path to the OBJ file into the mesh filtering mesh input and try to calculate it. And boom, the progress bar turned terrifying red. So that's why we needed to pre-process the mesh via the Mesh Decimate node first. So I'm setting the smoothing iteration to 1 in mesh filtering for some extra polish, and now it should be perfectly fine. I think it could be a bug of how Blender exports the OBJ files, or at the same time it could be a bug with how Meshroom interprets them. But anyway, now we know the workaround. Double-clicking on the mesh filtering node opens it up in the right panel. I think it is worth hiding the rest of the meshes to get a clear view on our new one. It's ready for texturing, I think. Before feeding in the second set of inputs specifically designed for texturing, let's try to process this node as is to show something. Namely, to show how the texture file type set to TIFF will look like, and generally to show how the overly sharpened file with cranked up contrast will look like. Hint, not great, not terrible, but you will definitely see the color management issue related to TIFFs. So double-click on texturing to preview it in the viewport, and if for some reason you don't see textures, it can be switched on in this menu. So as you can see, the diffuse texture turned out to be significantly visually darker than our input photos, in addition to weird contrast and sharpening that we did for better processing of geometry. That is related to how Meshroom does color management. Specifically, it used an EXR format under the hood for pre-processing the sources. And now, after spotting TIFF as a texture file type within texturing node, it basically converted everything to sRGB color space. But what would be the safer workaround to avoid any confusion with color profiles and stuff like that? We're going to sort it out in a moment. For now, let's right-click on the texturing and duplicate this node. Let's sort out two issues at once. First of all, let's connect the inputs designed for texturing into this node. And secondly, let's untangle the color management puzzle. In order to branch texturing like this, we would want to have two copies of prepared and scene node. So what can we do is duplicate this node and have a look at its settings. It should have the images folders drop-down menu where we can hit the plus icon and define the path to the folder with the sources meant for texturing. As a quick reminder, we had two folders, one for geometry, the second one for textures. The one for generating diffuse and later on albedo texture was slightly flat looking and as if deleted already. This one. Let me copy the address as text, Alt-Tab into Meshroom and paste it over here. Next, it would be brilliant if we connected the images folder output of this node all the way to the corresponding input of our second texturing node, if that makes sense. To cut the connection, I'm gonna right-click on it and choose Remove. I hope the user interface is big enough in order to see it. Anyway, now we need to connect the images folder input and output like this. It's important to not mess the connections somehow, and it is hellishly easy to do that actually. We need to be extremely careful with nodes. As for the settings, let's keep the texture side at 4K resolution. We can go slightly higher if we wish to, but I think 4K will be quite enough. The downscale at 1, meaning original resolution, and the texture file type to EXR instead of TIFF. Lastly, the unwrap method should be set to LSCM, otherwise Meshroom will generate a whole bunch of textures, like 10 textures instead of 1, and I think we would like to see the texture nicely packed into one file. It took approximately 10 minutes to generate the texture, which is not that bad. Let's double-click it to load up the preview in the viewport. Let's hide the stuff that is blocking the view, and here it is. An amazing Highpoly mesh with UV map and diffuse texture ready to go. It took us approximately 47 minutes to fully calculate this photoscan with texture in Meshroom, and actually I'm really satisfied with the quality. Maybe not so much with the processing time though. I wonder, what do you guys think? In my opinion, it's pretty good and usable as an asset, especially considering that's the free and open source pipeline. That is by itself mind-blowing, I think. As a finishing touch, let's take the model plus texture out of Meshroom via the publish node. The mesh and the texture as well should go into the input files. As usual, the output folder has to be defined. Let me create a separate one called Highpoly Textured and just drag it into that window. Right-click, go compute, and there it should be dumped into that folder that we have just defined. And indeed it is there. Perfect! So that is it for the first major part of the tutorial, where we managed to generate a pretty good photoscan mesh using 100% free, open source and cross-platform pipeline. In the second part though, we'll take this model and make it game ready by baking textures onto the low-poly version of this model. Hello and welcome to the second part of the free Photogrammetry pipeline tutorial, in which we explore the 100% open source, accessible and cross-platform pipeline for creating amazing photorealistic 3D from photos. In the previous video we used Darktable to develop our raw photos and Meshroom to generate 3D geometry. We also utilized Blender as a general cleanup tool. And in this video we'll use Blender as a baking tool to reproject diffuse, normal and even displacement textures onto the low-poly version of the mesh to make it game ready. As a refresher, that's how our raw scan made in Meshroom looks imported in Blender. You can find this file in the project files, feel free to download it. So currently this mesh is fairly heavy. It has 1.7 million triangles and faces for that matter, because it was triangulated. And once again, both the blend files and the OBJ file used for this tutorial can be downloaded. We'll require these files in just a moment to be able to follow along, so it's recommended to get it. So I think we're ready to start our Blender baking adventure. First, we'll need to go over to our import menu to get the OBJ file in. Click import. It could take a few seconds if it's heavy enough, but here we go. I'm gonna rotate the model so it sits on top of the grid, and to aid the rotation I usually set the origin to geometry from the right click menu, and then it's the usual business of snapping the object into place by utilizing G, R and S hotkeys for grabbing, rotating and scaling it. And it's easier done in the orthographic projections that can be brought up by the help of the numpad keys. Next, we should probably smooth out the normals of the object, so right-click, shade smooth. Actually, it's fairly important to keep the normals averaged or smoothed out before any kind of texture projection. To organize the scene a little bit and prepare it for baking, I'm gonna create a new collection and call it HP or Highpoly. And while we are at it, let's also rename the object accordingly. So Highpoly is the name. As you remember, we have had the diffuse texture somewhere. Let's hook it up to the principled BSDF shader. So here is the shader editor, and let's drag our EXR texture into it and plug it into the base color socket of the material. By the way, the color space is still set to linear, or it could be non-color, that's the same thing. Now, to be able to see this texture, we need to jump into the rendered mode in the viewport. Maybe I'll also increase the strength of the environment light. Alright, so the Highpoly version is approximately 1,700,000 triangles or faces. Our next mission objective is to derive the Lowpoly version by simplifying this monster. That's our plan. Let's duplicate the mesh and crunch down the density of polygons considerably. I'm renaming this object to Lowpoly and putting it into its own collection called LP. Probably the easiest way to turn the Highpoly version into its Lowpoly counterpart is to utilize the decimate modifier. If you have a look at the modifier settings, you will see the face count displayed at the bottom. Right now it reads 1,700,000 polys. If we enable the wireframe, we'll probably have a better taste or better look at how we crunch down the poly count. So the ratio of 0.1 reduces the poly count by the factor of 10, obviously, and what I usually like to do is apply the modifier and then add the second iteration of it. So modifiers, decimate. By doing it like that, we make sure that it behaves in a more responsive and fluent way generally, and it's just easier to fine-tune, I guess. So, reducing the ratio down to 0.05 or even 0.03 produces 5K faces. That should be totally fine even for real-time applications, I think. Removing the material just in case. And before giving it the green light, it's useful to preview it in the solid shading mode. I see some mesh artifacts that bother me, so I'm gonna increase the ratio ever so slightly and apply the second iteration of the decimate modifier. So this is gonna be our optimized version of the model with the face count of approximately 7,000 triangles. That should be an okay poly count for the modern game engine, kind of an average one for this type of an asset, I think. So now it boils down to making it look as cool and as high poly, I guess, as possible. You guessed it, via baking. There's just one more thing left to do before actually baking the textures. It is creating the UV map. So in the second window, I'm opening up the UV editor, selecting all the faces in the edit mode with the help of the A shortcut, then pressing U and selecting Smart UV Project as the fastest unwrap option, almost an automatic one. The defaults should be fine, let's confirm. After seeing this huge island that represents the ground, I think we can select it by pressing L, then S to scale it down a bit actually. And then select everything by pressing A, go UV, and let's pack it. Now the UV space is used in a slightly more efficient way that prioritizes the object and not the ground. Even though it's not perfect, it's much better this way. Now, when our low-poly model has been successfully unwrapped, we can figuratively put it in the oven for baking in the oven. Anyway. Alright, to keep the workflow free and open source, we're gonna be using Blender for baking textures in this part of the tutorial. It has a few minor quirks, but it's totally doable. So first of all, I'm gonna toggle off the visibility of our Highpoly mesh in the outliner and enable the collection with the Lowpoly mesh instead. As a quick reminder, it has been simplified to approximately 7,000 faces, and the UV map has been already generated as well. So our cunning plan for baking the displacement map from multi-res in Blender looks like this. First, we need to capture the details from the Highpoly mesh by adding the multi-res modifier and the shrink wrap modifier. That's our magic combo. We'll subdivide our multi-res a few times to give it enough resolution, then the shrink wrap modifier will capture the geometric details from our source Highpoly object, and then eventually these captured details will get pushed into the multi-res again so we can bake it as a height map. Don't worry if it doesn't make sense just yet, we'll get into the weeds in just a moment and we'll show the whole process. For now, let's actually don't forget to select the Highpoly mesh as the target for shrink wrap. To capture the full range of surface intricacies, we should probably bump the resolution within the multi-res modifier. So I'm gonna click subdivide, and that will increase the resolution of the geometry. And you can already see by its changing shape that it inherited the detail from the Highpoly mesh. That's shrink wrap doing its magic. So let's subdivide it once more for even better effect. And it's looking quite good already. Let's check how many polygons did the original model have. 1.7 million. So that is our target. That is the reference number of polygons we should drive our low-poly multi-res geometry to. Or rather triangles, because the low-poly model hasn't been triangulated yet. So currently it measures approximately 81,000 faces and 163,000 triangles conversely. So ideally the number of triangles after we subdivide it a couple more times should correspond to or be higher than the number of polygons in the reference model. So let's click subdivide once again within the multi-res modifier and let's see what the poly count will become. Alright, we got approximately 300,000 faces, not nearly enough, so let's try our luck at subdividing it once again. We should probably keep in mind that each next level of subdivision will make it progressively harder for computers to calculate, but anyway, if we take a look at the statistics, we'll notice that currently our multi-res mesh is 2.6 million triangles. So technically it's even more than 1.7 million triangles of the original Highpoly mesh. So that is more than enough geometry to capture all the detail. What about the quality of the shrink wrap geometry though? We can definitely tell that even though the form has been captured pretty well, there are noticeable artifacts. I believe that some of these pinching issues can be tweaked by changing the wrap method to target normal project within the shrink wrap modifier. But still, it needs some more work. And I'm not entirely sure that target normal project was an improvement. You know, that happens in computer graphics all the time. We think that we improve stuff while we actually make it worse. That's classic. We can tell by these overly thin polygons that something is way off with the mesh, so let's probably roll it back indeed. The nearest surface point then is our choice. And poof, now the pinching is gone. I think our faithful shrink wrap modifier did its best, so we can apply it. So all the changes caused by the shrink wrap modifier get pushed into the multi-res. It's very useful because that's what we are gonna be baking. Namely the difference between the final amount of subdivision within Sculpt and Render, which is set to 4, and the viewport subdivisions that will eventually be set to 0. That will be our difference between the low and high resolution that will end up being rendered as the height map. So let me switch the viewport levels back to 4. It's almost ready for baking, I think. But first we probably have to do something with pinching. It's no good to leave it like this. I think Sculpting comes to the rescue once more. So Control Tab, Sculpt Mode. T opens the left tool shelf with all the brushes. Now we need some kind of a smoothing solution. In addition to the smooth brush that can be invoked by pressing Shift and the flatten brush, we have a very intriguing one called Mesh Filter. We can click on Inflate and change the mode to Relax instead. And now just click and drag and watch the whole thing get progressively more and more relaxed. Until it is completely chilled out and there is no visible pinching, I guess. Awesome. Simply awesome. I think we have prepared the multi-res data for baking. Now it's time to actually bake it. Finally, I'm going back over to the object mode and I'm preparing mentally for the baking process, which is gonna be a little bit hardcore. Probably the biggest weakness of Blender compared to other baking tools is its inability to bake height maps from one model to another. Fortunately, we have this multi-res displacement baking workaround, where we bake detailization from the higher sculpt levels to the lower, but still it's not quite there. It's still not as intuitive as some other baking applications. That being said, by prioritizing Blender as our baking tool, we keep this workflow A, open source and free, and B, cross-platform. That's a major advantage, so let's roll with it. So what we're gonna do is bake 3 maps. The displacement map from multi-res modifier, the normal map from the Highpoly version of the model, and the diffuse map or the base color map from the Highpoly version as well. Let's start with the trickiest one, the height map. The basis of how the multi-res displacement baking works is that it takes the difference between the sculpt subdivisions and the viewport subdivisions, and it bakes this difference as a displacement map for the minimal subdivision level for the viewport. It is important, even crucial, to define what is our minimal level viewport subdivisions that we are baking for. In this case, we zeroed it out, so that's our minimal level. Okay, as Eevee currently doesn't support any kind of baking, we should switch over to cycles instead. It is very easy to miss this step and go, where are the baking settings? So, cycles. And as for the samples, we don't need that much. Actually, just 8 samples will be quite enough for the type of baking that we're aiming for. Now we have the bake from multi-res checkbox ticked and the bake type set to displacement. That's practically all we need for our multi-res height map baking workaround, our secret sauce of baking displacement maps in Blender. Now in the upper left corner of the UI we have the shader editor. I have created a bunch of blank image texture nodes in advance. Basically you can add those image nodes from the Shift-A menu. I just did it in advance to save some time. So let us zoom into the first one, that will be our height map, and press New to create a new image file. We can be brave and set the resolution all the way to 4K, knowing that the baking process will actually be super fast. Let's call it displacement_bake. And it's also crucial to enable 32-bit flow checkbox, otherwise the displacement will have this weird stepping effect. After a new texture has been added, it can be found in the image editor. For now it's just black. I think we're ready by now to press the bake button with the displacement_bake image texture selected in the shader editor. That's important. Oops, no objects found to bake from. I think we simply forgot to do something. We forgot to select our object in the viewport, most likely. We can either click on it in the viewport or in the outliner. We should tell that it has become an active selection indeed by seeing an orange outline. That was easy to fix, right? Now let's click bake again, and it should go without a hitch. Luckily it's so fast to bake this type of texture, we should see it almost immediately in the image editor. Let's just pack it or save it externally, however you like. Otherwise we will lose it on quitting Blender, and that will be such a shame. Packing textures instead of saving textures has its own advantages and disadvantages. I did it to save some time. And anyway, the packed textures can be extracted into the folder with the blend file automatically. It'll even create a nice folder named textures for you conveniently. But if you're gonna save images by going image, save as, that's totally up to you, that's fine. Alright, what should we bake next? Now the second texture will serve as a normal map, so let's click new, call it normal_bake. The resolution is set to 4K, let's disable 32-bit float now, and hit OK. Once again, it is important to select this particular image texture that you're going to be baking to, and with that done, the bake type can be changed to normals. So after selecting the normal underscore bake image and hitting the bake button, we should see the progress bar firing up at the bottom of the screen, and if everything goes right, get our normal map. Oh, the time flies, just a few seconds passed and we already have the normal map generated. Let's preview it out in the image editor to see if everything seems to be correctly generated. And personally I have no objections, I think everything looks smooth. Now let's see what is still left to do. Well, first of all, before I forget, let's set up a proper displacement chain. Here I prepared an empty image texture coupled with the displacement node in advance. Let's disconnect it, move it to the left like this, and let's use the height map or displacement that we have baked from multi-res modifier. And it should go into the height input of the displacement node. Okay, and this empty texture node will become a holder for the base color texture. Clicking on new and calling it just like that. Base color underscore bake. The base color texture doesn't have to be the 32-bit float image, so I'm leaving this checkbox empty. And confirm. Don't forget to pack the textures or save them externally for that matter. This time we won't use the multi-res modifier as a source of baking data. We will use our Highpoly mesh with the diffuse texture instead. So let's toggle the visibility back on in the outliner. Select the Highpoly, then control-click on the Lowpoly and make sure that that's the last object selected. Now we need to come over to the bake settings and change the bake type from normal to diffuse. Here it is. We are interested in the base color only, so both direct and indirect contributions should be turned off. Then it's absolutely crucial to get the selected to active checkbox ticked. That's why we have two objects and we are baking from one to another. As for the cage, we won't be adding a custom one. What we need to do though is adjust the extrusion. It creates a ballooned out version of a mesh to cast the rays from, so it's a safe bet to set it to a lower number like 0.01 or 0.02, something like that. Let's check the Highpoly model though first, because I have an impression that we have lost the diffuse texture somewhere. Let's check it out. I'm disabling the visibility of the Lowpoly, switching to material preview so we can preview the diffuse texture, and indeed it looks blank. It looks like I managed to lose the diffuse texture along the way somehow. Let's inspect our Highpoly, and indeed, where is the texture? What's going on? That is awkward, but what I usually do in such cases is search in the image editor. And actually, here it is. It just has to be plugged back into the base color. So I click and drag it like this, and it goes into the base color. Hopefully that will bring things back to normal. So with this issue fixed, we can give it another try. I selected the Highpoly model first. Then let's enable the visibility of the Lowpoly one, shift click on it. Then we can try to hide the Highpoly temporarily to see what we are doing. And it is super important to select the texture that is going to be used for baking in the shader editor. And with all the rituals fulfilled, we can at last return to the baking menu and hit the button again. Whoops, it prompts an error, no valid selected objects. I think we need to enable the visibility of the Highpoly mesh as well. That should do the trick. And then select both meshes, with the Lowpoly being the last one, and hit bake again. We can see the progress bar firing up, and that's the good news for us. Well, what's going on? Why the texture is black? We should probably disable multi-res modifier and try that one more time. You see, it's a bad omen to say the good news, because there is no good news in computer graphics until you actually see the rendered result with your own eyes. Baking again. So after a few miserable attempts of reprojecting the base color from Highpoly to Lowpoly, we succeeded, and that's a good news, folks. Now we just have to save the image, or rather pack it. From now on, it will be a part of the blend file. And now it's time to build the material. So base color goes into the corresponding input of the principled BSDF shader. And as you can see, it looks pretty lifeless and flat. That's because we need to reconnect the rest of the inputs. Yes, our baked normal map, I'm talking about you specifically. In order to work properly, it needs the normal map node from the shader editor. It can be found in the vector tab. And before we use this normal map, it's important to switch the color space to non-color or to linear. Otherwise the bump mapping will look terribly off and totally crazy. So it goes into the color of the normal map, and then it is silently hooked up to the normal input of the material. Alright, that's looking much better already. To take it to the next level, we can make use of the displacement map that we have generated. As a quick refresher, the displacement map setup in Cycles looks like that. We have the baked height map, which goes into the height input of the displacement node in the shader editor, and in turn, this displacement node goes straight into the material displacement input. Then, to finalize the micropolygon displacement setup in Blender, we need to do a few things. First of all, we need to set up the subdivision modifier. Here we go. And enable the adaptive subdivision checkbox within this modifier. If you don't see the adaptive subdivision checkbox right away, it means that the Cycles feature set should be switched over to experimental first. And then the checkbox with the new option should appear in there, and it has to be ticked. But that's not all. Lastly, we need to visit the material settings. Scroll down all the way to the bottom of the settings until we see the displacement drop-down menu. There we need to choose displacement only. And hopefully after all these manipulations, we would be able to enter the rendered mode in Cycles and see the micropolygon displacement come into play. After some testing, we found out that after baking the modifier from multi-res data, the scale of the displacement node should be set to something like 0.05. That practically makes it look very close to the Highpoly version of the mesh, and so we think that's pretty close. Evidently, the scale of 1 is way too strong displacement for the height maps produced via baking from multi-res. So the scale of 0.05 seems to be the sweet spot. And in addition to that, the mid-level should be set to 0.5, but that's the default value for it, so we don't have to worry about it that much. It is worth comparing two meshes to make sure that we nailed the displacement settings indeed, because it can be pretty tricky to do right. So here is a quick comparison between the raw Highpoly scan at the bottom and the Lowpoly version of it with the Cycles micropolygon displacement at the top. These two models look fairly similar to me. I think we can write it as a success. If you feel like watching a few more comparisons, here's how it looks in Cycles with micropolygon displacement turned on. Pretty awesome. And here is the same mesh, but rendered in Eevee this time without any displacement. Just a good old normal map applied. And in my opinion, that also looks pretty cool and detailed and realistic. It is still based on the photoscanned asset, and that's what gives it its charm. Obviously, the realistic clothy stuff like that is notoriously hard to make in 3D, so starting with a photoscan is a blessing. It is amazing how far we went with the open source cross-platform photogrammetry pipeline, right? It is crazy to think that we can do all of this without buying any kind of software. And even though it's far from being the fastest workflow ever, and if you want the fastest workflow ever, which still consists of 90% open source software, check our course, the link is in the description. But anyway, that's super impressive that we can set up the full photogrammetry pipeline by using only open source and only cross-platform tools. That makes this entire workflow super accessible pretty much to anyone. The only bottleneck I see currently is the hardware issue rather than software issue, which is an NVIDIA GPU is still required for most of the operations in both Meshroom and reality capture, if you're gonna use reality capture for the same thing. Aside from that, that's super accessible, really. Thank you for watching. My name is Gleb Alexandrov. You're watching Photogrammetry course, in which we explore various ways to create amazing photorealistic 3D from photos. Make sure to check the full course if you want to learn more. The link is in the description, and join our Creative Shrimp Discord community where we talk about all kinds of things, including photogrammetry. See you there, drink more coffee, and we'll change the world of computer graphics.